So we're going to be graphing roots today. And as you know, that roots are just simply the inverse functions of powers, right? So if we know how to graph, let's say, this function, f of x is equal to x squared, and we've learned about how to graph inverses, right, of reflecting over a certain line, then we should be able to graph its inverse function as well. Does that make sense? Hopefully that's how our activity that we did last week, where we reflected over the line y is equal to x. That was so we could extend our thinking, and so we could graph anything. If we know how to graph one function, we should be able to graph its inverse function pretty easily. So that's where we're going to start today. What shape is made by this graph, f of x is equal to x squared? What shape is that? It's not a straight line. We spent 9 weeks graphing these. Yes, I'm seeing a lot of you make the line, make the shape. Parabola. Wow, okay, so parabolas, this is what we would call the parent function for all parabolas that have a vertex point at the origin, and it opens up, right? We're just sketching this. We're not going to get a bunch of specific points, but that would be the parent function for a parabola, for a quadratic. So now let's talk about what if we wanted to graph its inverse. Remember that paper folding activity we did? And the inverse functions are always reflections over this line. Okay, so let's try to graph the inverse of this. Let's try to reflect it over that dashed line. So I would start with the part that's the curved part that's really close to the dashed line and do this part of it. Does that make sense? Because that's the easy part. And then maybe this arrow part would look something like this. Now this other part of the parabola might be a little harder to graph the reflection. Now we're not changing the shape, we're just changing really which way it opens. Can you tell which way it's going to open? Like instead of opening up, it's going to be opening up sideways, isn't it, to the right? So let's not think too hard about what this is going to look like. Does it make sense it would look like this, opening up to the right? It's still a parabola. We just simply reflected it over that line, and now it's opening to the right. So that should be f of x is equal to the square root of x. Does anybody see a problem with that if we're calling this a function? Does anybody see a problem with that if we call that a function? Yeah. Yeah, go ahead. The line check thing, yeah. Call that the vertical line test? Anybody remember that? Yeah. Vertical line test, it wouldn't pass it, would it? It would not pass the vertical line test. So if we drew a line like right here, like maybe where x is 7 or something, we would have two outputs. So we would have an issue with the fact that this is not a function. If you have one input of 7 and two different outputs, then this is no longer a function. So there was a problem with this. So the inverse is not a function. So what they did in order to solve that problem, whenever they graph the square root of x, this is what they do. Instead of doing the whole sideways parabola, they just do the positive arm of it. It's like a half a parabola. It's just a half of a parabola. This is what we call the parent function for the graph f of x is equal to the square root of x. We are simply sketching these, which means we're not finding a whole bunch of points. We're not getting very specific about exactly where all the other points are. We could, of course, if we wanted to. But can you remember that shape? The one point that is important is the starting point. And then the parent function, the starting point is at the origin. And so it's just like a sideways parabola, but it's just the upper arm of it. And for all of the square root functions that we're going to be graphing today, they all have exactly this shape. Does that make sense? So every time you see a square root, you're going to think of that shape. All right. Now, on all the problems that we've been graphing so far, pretty much domain and range has been all real numbers. We've been able to put anything we wanted in for x, right? We've been able to put in negative, positive numbers, zeros. We've been able to get all types of answers out for y, positive numbers, negative numbers, zeros. But now we're in a situation where that's not the case. And so we need to be specific now about our domain and our range. So we're going to look at domain. When we say what's the domain, this is what you should be thinking. What can, or what am I allowed, what can I put in for x? That's the question you should be asking yourself. What can I put in for x? Because everything has to be put in real numbers. You can't get imaginary numbers. And so we're not allowed to put just anything we want in for x. Can anyone describe for me what we're not allowed to put in for x? I heard negative numbers. Do you guys agree? Yeah. We can't put negative numbers in, can we? Can we put 0 in? Can you put a 0? Can you take the square root of 0? No. Everybody take out your calculator and see if you get an undefined. See if you get undefined or see if you get 0. If you get 0, then it's fine. If you get undefined, then it's not. Can you take the square root of 0? Yeah. Which makes sense because, look, you have the point 0, 0 there, don't you? Isn't the point 0, 0 part of this graph? That means you're allowed to put a 0 in for x. And what do you get out? A 0 out for y. And so 0 is allowed to be a part of your domain. So how can I write that you cannot use negative numbers? We don't want to write a sentence saying, hey, don't use negative numbers. So how we write our domain, two different ways I'd like to see you express this. You're going to write x is greater than or equal to 0. That's one way. You want it to be inclusive of the 0. If you just wrote x is greater than 0, then it would not be inclusive of the 0, and we would have an open circle at the origin instead of a closed circle. So x is greater than or equal to 0. That's one way to say it. Another way to say it is using what we call set notation. And this is what method you're going to be using at the next level of math and at every level after that. So it's kind of a transition year where you're going to be using both. In set notation, it kind of looks like a coordinate, but it's not a coordinate. It tells you where it starts. So you start with your smallest number. Then we're going to use a comma, and then it ends with the largest number that are all the values of x. The smallest number for x is a 0, correct? And because it includes the x, we are going to use a bracket, like with the sharp edges. If it did not include the 0, we would have used a parenthesis. So we're going to use a bracket here. That includes a 0. Now, where does our x values end? What's the biggest x value we can put in? I can't put in a 6? Can I put in a 7? Oh, it doesn't end. Infinity. Are you with me on that? It's infinity. So how we write that, we use the infinity sign. And because infinity has no end, we cannot use a bracket A bracket would like ends it and includes it, so we use a parenthesis at the end. So that's what we call set notation. So that's our domain. I'd like you to see it written both ways. X is greater than or equal to 0, and bracket 0, comma, infinity, parenthesis. Let's talk about range. Because it doesn't end. So I can't use a bracket there because a bracket says, hey, include this number and end it here. And because it's a concept that it never ever ends, then we have to use a parenthesis. Our range, the idea here is, what are the y values, right? What are all the possible y values? So how does this look? What are all the possible y values? What's the smallest y value? 0. What's the biggest y value? Infinity, you bet. I don't know. He's got a thing with 0 or with 5 today. Y is greater than or equal to 0. So it kind of works the same way, from 0 to infinity. We're going to write it in both ways. Okay, any questions there? Yes, sir.
Can you list it the opposite way? It doesn't matter if you like.
Can you start with the infinity sign and then? Yeah, you cannot do that. You have to put it from smallest to largest. Yeah. So here's the good news. When we were graphing absolute value functions, when we were graphing parabolas, we could translate or move our figures left and right, up and down, right? We could have it open down instead of open up by doing different things to our equation. And the rules are still the same here, which is nice. We don't have to learn a new set of rules. So if I had this function, f of x is equal to, and I had square root of x and then plus 3 on the outside, I want you to turn and tell your neighbor or someone else around you what happens to the parent function. How does it move? What direction and how many spaces? Quickly, tell the person next to you. Tell people around you. All right, so let's hear. What do you think? What do you think? Mom, what happened to all the other stuff that we grabbed? Huh? He says down 3. What do you guys think? So you said it goes which way? Up 3? What do you guys say?
I'm saying
Up 3 as well? Right, you say right?
I said up 3.
Up 3? Up 3? Okay. So since it's on the outside of the square root sign, it's not inside with the x. You with me on this? Think about if we had a table for this original parent function, and we had our x value and our y values. The only thing that would change would be the y values. Are you with me on that? It would just be you're adding 3 to every y value. Think about what that table would have looked like originally. If you put a 4 in for x and you took the square root, you'd have a 2. Right? If you put a 9 in for x, you would have had a 3 out for y. You with me? So that would have been your original parent function. The only thing that changes here is we're adding 3 to all of the outputs, to all of the y values. So now what do you think is going to happen, everybody? It's going to go up. All the y values are going to be shifted up 3 spots.
What was it that went down?
That would be a minus 3 at the end. Okay? So listen, the parent function would have been at 0, 0, origin, but we're moving that up 3 spots. So now that's the important spot. We are sketching. We are not graphing specifics. So that is the only really point I need to see, and I just need to see that you're sketching the half of the parabola moving to the right. It's not bad, right? Okay, domain and range. Domain. What's allowed to be put in for x? Did it really change anything from the last problem? Not for real, because look, the square root hasn't changed, right? It's just still square root of x. So our domain is still greater than or equal to 0. It's still from 0 to infinity. That hasn't changed. But what has changed? Our range has changed. Okay, so what's our range?
That's 3.
Y is what?
3. Yeah, why?
Y is now greater than or equal to 3. So you should probably write this down in your notes so you have a good thing to look at later on. So that time your range changed. So just like all the other things we've graphed, whatever is on the outside, right? If it says plus 3, it goes up 3. Minus 4 goes down 4. Because it's not with the x. It's only affecting the y values. It's only affecting the output. That's also why it only affects the range. Does that make sense? What if I want it to move left or right? Where do I put?
Oh, that's gonna be like
Where would I put the plus 3 if I wanted it to move under the sign? Yeah.
oh yeah, it's like
So if I write the square root of x plus 3, in which direction does this move? Does this move to the right or to the left?
To the left, because that thing we did on Desmond's.
Oh, you remember the activity we did on Desmos. That's good. But some of you might have thought, I think it moves to the right. You know, some people might think that, right? Well, here's all you have to do. Let's say that you mistakenly thought that that moved to the right and you graphed it like this. Correct? Let's say that's what you thought. There's a very easy way to check your work. What point is this one right here where it starts? 3, 0, correct? That means what you're saying is if you put a 3 in for x, you should get a 0 out for y. Well, does that happen? No. You don't get a 0 out for y. And that should alert you to say, oh, wait, something's wrong. I thought that it moved to the right, but it clearly does not. I got to put a negative 3 in for x if I want a 0 out for y. Does that make sense?
yeah.
Always check yourself. You're only plotting one point. So that makes it very easy for you to check your work. Okay, domain and range. Shh, write it down.